Hello PLP geometry. Welcome to the next video in Unit 3, more with triangles. We're about halfway through the unit. And just like last video, we talked about perpendicular bisectors and the circumcenter. We're going to talk about another similar idea. Okay. So again, we're in Unit 3, more with triangles. And again, so this is video number 4. And this time, we're going to talk about angle bisectors. So angle bisectors. And what's called the incenter. So you'll see that these notes are very, very similar to the structure of the last of the notes. Again, we'll talk about how to do a construction of this in Desmos geometry. Okay, and then you'll be responsible for doing one in Desmos geometry as well. So first off, let's talk about the angle bisector theorem. So the angle bisector theorem. Okay, so the angle bisector theorem states that any point on an angle bisector of an angle is equidistant, again that means equal distance, is equidistant from the sides, of the angle. And in parentheses, I'm going to put perpendicular distance. As you'll see in the example, or the image I draw, you'll see where that perpendicular comes into play. So let's start with an angle. Let's call this angle A. So I'll just draw it like this. So there's one of the arrows up here, one of the arrows up there, and this is my A. Okay? So what I want to do is I want to draw an angle bisector. So again, if I think of this as angle A, if I try to split that arc in half, do your best, almost straight up, probably not perfect, but there you go, right? So again, what I've done is I've created, and I'll draw another set of arcs, this angle congruent to that angle, right? So what this means is if I'm a point on this angle bisector, let's call me point P, then I will be the same distance or equidistant from the sides of the angle. And to get that distance, we have to go perpendicular from P to the sides of the angle. So again, perpendicular means make a right angle. So if you can see this from P, if I go in this direction, there's a right angle at that side. I'm going to call this point right there B. And if I do the same thing on this side, and again, you see my picture's not perfect, right? And there's my point on C. Those two distances should be the same. So P to B should be the same as P to C in this picture. And again, that is how you know that a point on the angle bisector is that it is equidistant from the two sides of the angle. Okay, so how is this going to help me find the incenter? Well, let's read on, right? So if we're looking for what's called the incenter, so we are looking for the point of concurrency, and again, that just means intersection, so point of concurrency or intersection of the angle bisectors, of a triangle. So I'm going to make this triangle kind of big because you're going to notice that the incenter is always in the triangle, and we're going to draw what's called the inscribed circle, which is always in the triangle as well. So if I draw another acute looking triangle, and again, I'll just make it a little bit bigger this time. Okay, so let's call this triangle A, B, C. All right, so again, I'm looking to draw two angle bisector. So let's bisect angle A. So again, if this is angle A, I'm going to try to go through that angle and split it in half as best I can. And again, you can go as far as you want to and probably stop right around there. Okay? So again, what I've done is I split angle A into two congruent angles right there. Okay? Let's do the same thing for angle B at the top here. So here's angle B. Again, if I look at that arc, try to split that arc in half. Okay, go down through. And there we go. So again, now these two angles, I'll use two arcs on each side, are congruent. And if I mark that point of intersection, let's call that point P, that is going to be the incenter. So P is the incenter. P is the incenter. Okay, now to draw this circle, what we need to do is we need to find the radius, right? And again, if we go back to the angle bisector theorem, the distance that P is from each side of angle A should be the same. So if I go perpendicular from P down to this side right here, this side of A, make a right angle. Let's call that point X. And if I draw a perpendicular from P to this side of angle A, perpendicular, let's call that point Y. Those should be the same. And again, I know they're not in my picture, but they should be the same. Again, so P to X should equal P to Y. Now, if we do the same thing for P and angle B, so P to Y is that distance from this side of B. If we go over here, there's my right angle. Let's call this point Z. Now, these two should be the same. So P to Y should be the same as P to Z. And now, since they're both equal to P to Y, P to X should also be equal to P to Z. And now these will act as the radii of the inscribed circle. So if you go ahead and try your best to draw a circle including points X, Y, and Z. So I'm going to start with Z. I'm going to go to Y. Come back down through X. Trying to go outside the triangle if you can. And there we go. So again, that's my best shot. But there's my inscribed circle. And again, you do your best job too. That's all we can ask. Right? But that circle should be in the triangle touching all three sides. Okay, so let's talk about the steps to constructing this. And then we'll use Desmos geometry to construct it. Okay, so we are going to construct an inscribed circle. So again, I'm not going to redraw the steps, but you can see above how I walk through them. So we are going to be given a triangle. Okay, so step one, we need to construct the angle bisectors of two angles. We're going to mark the incenter. And again, the incenter is going to be where those two intersect. So it's the intersection point. Once we have the incenter, next we need to construct a perpendicular from the incenter to one side of the triangle. To one side of the triangle. This again is going to give us our radius, right? That's the distance we are from the side of the triangle. And then step 3, we need to use a compass. Use a compass to make a circle. Using the segment from step 2 as the radius. And this is how we'll go through and construct an inscribed circle. So again, that step 2 is different than the circumscribed circle. So we have one extra step to do. Okay? So let me show you how to do this on Desmos geometry. You will have to do this as well. So make sure we pay attention. All right. So in Desmos geometry, again, clean slate. First thing we do is we draw a triangle. Again, I'm going to make mine acute. Make sure you don't forget to finish it. Okay. Next thing you have to do, before you can do the angle bisectors, you have to create 2 angles. So this button is the angle tool. If you click on angle, so now we name the angle with 3 points, right? So if I want to get this angle right here, okay, I am going to mark it using 3 dots here, here, and here. And see how it shows up at the middle dot? So that's important, right? So I did this angle. Now let me do the top angle. So that's going to be my middle letter. So I'll go with 62. Then I'll go with the top. Then I'll go down here. So there are my 2 angles. Okay? So these are the 2 angles I'm going to bisect. So now, if I click on this segment looking button, right? This one, notice here it says angle bisector. Now that I created those 2 angle bisectors, notice I can bisect them. Notice I cannot bisect that angle because I didn't create it. So make sure you create the angle. That's something to do in Desmos geometry. It might be difficult for you. So if you click on the angle bisector shows up. Click on the angle, shows up. There we go. Now I'm going to click the point tool and mark the point of intersection right there. That is going to be my incenter. Okay, so now step 2. So that was step 1. Create the 2 angle bisectors. Step 2, we are going to construct a perpendicular from the incenter to one of the sides. I'm going to pick this side on the left here because I have like kind of the room to do it. So if I click on that tool right there, right next to the dot, next to the point tool, here's my perpendicular. So I'm going to be perpendicular to this line going through this point. And there is my segment. This right here, from here to this point, I'll make that point show up. This right here is my circle's radius. That could be tough for some of you, right? So now the last step is to grab the circle. I'm going to click on this incenter. Then I will click on this point. And there is my inscribed circle. Notice that it is in this triangle and it touches all 3 sides. If I move the triangle, notice that it stays inscribed. Notice if I make this angle a right angle, which means 90 degrees. Notice it stays inside. Notice if I make it a little obtuse. Notice it stays inside. So the inscribed angle is always in the triangle. The incenter is always in the triangle. Okay? So again, you're going to have a short delta math, and then you have to do one of these constructions and show me, and then you're done with number 4. All right, thanks for watching. Good luck.